So in 9.2, we're going to look at lines of fit, specifically the line of best fit in a given set of data. So the line of best fit. Okay, so we want to think about that. If we have a set of data and we have a bunch of points like this, is the line of best fit going to be something like that? No. What about something like that? Not quite. What if it was something like this? You see about half the data points are on this side of the line, and half the data points are on the lower side of the line, on this side, and this line of best fit goes straight through the middle, right? Okay, so think about it. Your line of best fit is going to have about half of the data points above it and half the data points below it. And it doesn't necessarily go through specific data points, but then given 2 points on the line, they do not have to be data points. Again, they do not have to be data points. So once you draw the line, just pick 2 points from the line. So you could say this point, and let's say that this one is 2, 2, and that this one is 5, 4. Now, given 2 points, can I write the equation of the line? Yes, right? We have step 1, find m, with m equals y2 minus y1 over x2 minus x1. And then step 2, plug in m and one of the points into y equals mx plus b, right? We would plug in rm and then one of these coordinate points, and then you would solve for b, and then you rewrite that as y equals mx plus b, right? So you fill in the m and the b, and there would be your equation for the line of best fit. So if you were, well, let's look at an example. So the table shows the depth of a river X months after monsoon season ends, right? So here we have X and Y. So X is the number of months after monsoon season ends, and Y is the depth of the river. So we're given all these data points, right? And we just, step 1, you plot them. So you plot, here we go over to our graph, and we have just plotted these points all along there. So once you have these plotted, now you can draw the line of best fit. So think about it. You want half your data points below, which we have like 1, 2, 3 on this side, and 1 here, 2, 3 on that side, and going through one of the points there, right? So it's about half and half of the points on each side of the line. And the line does go through a few of the points, right? We have 5, 10, and 6, 8 there. So let's just use those two to find our slope. And then use the slope and the y-intercept, which we can see right here is 20, right? And we can write our equation of the line. And at that point, you can head to C, interpret the slope and the y-intercept of the line of fit. So let's go ahead and do this. So we have m equals y2 minus y1 over x2 minus x1. So we're working on B right now, right? An equation of the line. So we have to find the slope. So we have 10 minus 8 over 5 minus 6, and that equals 2 over negative 1. So our slope, m equals negative 2, right? And I'm now going to shrink this and just move it over. So now that I have my slope, I can take y equals mx plus b. So I'm going to just use 10 equals negative 2 times 5, right? I'm using this 5, 10 right there, that point, plus b. So I get 10 equals negative 10 plus b, plus 10, and you get 20 equals b, right? So now I take that, and I get y equals negative 2x plus 20. Okay, and this piece here I really didn't need to do because I can see that the y-intercept is 20, but just as a memory refresher, I went ahead and solved for b there. So now we have the equation of our line, which takes care, we've made the scatter plot, right? So that was A in the question. We made the equation of the line, that was B in the question. Now we're on C, interpret the slope and y-intercept of the line of fit. So what does negative 2 represent? If x is the number of months after the monsoon season ends and y is the depth of the river in feet, what does the slope of negative 2 represent? Well, it means that every 1 month the river's going down negative 2 feet, right? So after 2 months it's going to go down 4 feet, right? Because if we have 20 as our starting point and a negative 2, after monsoon season ends, the river's going down negative 2, so going down 2 feet per month. So that would be your interpretation of the slope. And the y-intercept of 20, that would mean at the very end of monsoon season, as soon as it ends, so 0 months after it's ended, the river's at 20 feet. When x is 1, so 1 month later, it's going to be at 18 feet. After 2 months, it's going to be at 16 feet, right? Because you're just plugging in the month for x, and then you're getting y, your new depth. So now we've interpreted C, we've interpreted the slope and y-intercept, and now D predicts the depth in month 9. So you would just substitute, so you would get y equals 2 times 9, or negative 2 times 9, plus 20. So y equals negative 18 plus 20. So y equals 2. So in month 9, the depth of the river is 2 feet. And does that make sense? Here, if we put 9 and 2, do those fit? Yeah, because as the month goes up, the depth goes down. All right, so there's our answer. That's how we have used the line of best fit to analyze a set of data.